Good morning, it's 10 a.m. It's about time to start continuing the adventure with version 5. My name is Rafał Kowalczyk and I will have the pleasure of making the presentation part of our webinar. On the other hand, with me is Marcin Krzyżanowski, who moderates the chat that we handle your question asked this way. At the end, we will have a little stage to respond to any questions that you direct to us. Today's webinar focuses on the calculation aspect of the heat load. The topic is also a direct continuation of the webinar conducted by me on the preparation of the building structure. We start with our promotional slogan. It's give me 5. The first step that we follow today are the direction of literature. Marcin Krzyżanowski, who is moderating the chat today, is also acting as editor in English. Currently, and there are 3 articles about our software. They basically talk about what our version 5 is and what's new for you. You can also download them to your resources. Please follow our social media. Okay, that's our LinkedIn. Especially the InstalSoft LinkedIn page, which we launched some time ago. You can find 2 of 3 articles about our new software, InstalSystem 5. Of course, I invite you to follow, read, and subscribe. Version 5 is becoming more and more visible also in foreign markets. And the second thing is our price list. The price list is available on our website. I have already allowed myself to open this price list to show you in a full glory. So maybe I open this list. The price list already includes the pricing of all modules that are available to you or will be available by the end of this year, with a special marking next to the next modules. At the moment, the last module that is happening is our sewage installation, which are in the beta testing phase. By the way, if you are interested in such a test, please ask for information in a chat to Marcin Krzyżanowski to obtain licenses. Please contact us directly to our general email, which is available on our website. You can find this email on contact section. That's our email. Since we have a mailing list for you, people who would like to get such a full license and participate in our webinar will receive, I think, a discount or more from us when order more licenses. Maybe I'll open today's plan. Ladies and gentlemen, we will talk about it in detail today. Today, I will guide you through our webinar today through the project I led in the previous building structure preparation webinar. Maybe I open this project. It's a short and easy project that can be prepared in our program in several dozen minutes. In addition, I have prepared other more complicated object for you, which I have prepared for today's webinar. These are files based on 2D underlays and beam files. The whole webinar can be set is connected with the related to the preparation of the building structure and the webinar that is available on you for you on our channel. And especially the beam design, which is also conducted with you at the beginning of this year. You can find this webinar when you go to our YouTube channel, and we have special stage InstalSystem 5 webinars and tutorials just for you. The plan for today's webinar is as follows. It's a presentation of tools and recommended design path for calculation of design heat load of the building and its rooms in InstalSystem 5. First, we talk about the available methods of determining design heat load. Then I talk about the new program interface for efficiently performing detailed heat load calculation. Then the main stage will be the recommended path of using the program with description of individual stages and selected aspects of the calculation. We talk about the standards, how to define the properties of thermal partitions. I talk about the new function like graphical grant and how to make the dormers in InstalSystem 5, something about how to assign definitions to our logical partitions, and so on. We talk about the verification calculation, and of course, finally, together with Marcin Krzyżanowski, we will focus on your questions and ask answers to your questions. The plan is also ambitious. Please reserve your time for over an hour. Okay, so maybe I open the project, the main project. What you see in front of your eyes is the effect of our previous webinar of the structure of the building. I hope that some of you participated in the previous webinar. If not, then of course I invite you to our YouTube channel in the English section. It shows exactly how to get to this stage. Before we get into design process, which you will present as part of the full building structure, the first thing what is important that if you want to get the heat load, full heat load calculation, you need to have full building structure. Maybe we will remain in this view, and maybe I use the function of hide all walls in 3D view. And now let's move on the general data to room data. Just click on Windows and General Data and Room Data. Okay. First, we talk about the method of calculating. First, you can directly impose this value using the user-specified method. So in each of the rooms, you can declare the heat load of room yourself. You can simply select based on the coefficient that we declare in general from this field for our rooms by switching according in this list. Obviously, this coefficient is, you can modify this coefficient in the context of, for example, types of room. When I click, for example, to living room and go to the data table, for each type of room, you can declare your coefficient, yeah, your heat loss index. You can use those proposed for a selected standard. You can also create your own. You can also create your own types of rooms from this level and declare appropriate coefficient for a given type of room. I also declare another. You can also declare another internal, for example, temperature. In other settings in data table, So here we have all this information on the right side of our program. In addition, if you already have rooms drawn manual or automatic in 2D and 3D, 3D view, in the data table, you can define this value individually for each room or set individual settings depending on your needs and design goal. Just go to the construction and, for example, I can click on the room, okay, and here you have the information about the coefficient and, for example, the design room temperature. And the default settings come from our general data. It's also important that the room itself must have a checkbox checked that it's a heated room. So briefly speaking, to each type of room, you can determine whether a project, whether in groups or individual two rooms, this value you can put. For these two options, you do not need the full building structure. The full building structure is not required. Okay, maybe I go to the general data again, because we, on the other hand, we will focus on the third options, calculation according to standard. So we can calculate the full heat load. What I started with, calculating the heat load of rooms is based on automatics rooms. To obtain such rooms, you must have the full structure of building, horizontal partitions, vertical partitions, sub-partitions, for example, windows, doors, and openings both vertically and horizontally. This has to be recalculated by this button, which is our building structure calculation algorithm. Based on the correct calculation of the building structure, we can approach the calculation according to the standard. This is our beginning. In version 5, there is no possibility of tabular calculation of building that does not have its graphical representation. Certain elements can be added tabulary or deleted, but when it comes to the object itself, this is not possible. We base on the graphic structure of the building, which is the entrance to our project. This is basically has only advantages that you will see for your designing process. The structure of the building itself is made very quickly, I think, because thanks to our new mechanisms and new BIM modules, I think that creating such a building structure is a big pleasure. We at InstalSystem 5 more focus on feeding the data that we get in the preparation of full calculated structure. I will show you all the main methods of which we can make the main path and how to make the automatic assignment. After maybe this theoretical introduction, we will start our adventure with the thermal load from general data. So I go to general data again, and I will focus on some aspects of general data. Maybe I go to the project scope. People who already familiar earlier with version 5 noticed that our software includes all modules in one application. These modules depend on your license and can be set in this window. Depending on what scope they are enabled, our interface sets, for example, the general data, toolbars, and functionality data accordingly. the program adapts to the given scope. Today we will base on the thermal calculation of the building. Those who do not have contact with our program, all these configuration options are located in this application here. Let me remind you that in the previous generation of our program, the application for calculating the heat load was a separate application. Here, everything is in one program. This basically has only advantages because everything is compatible with each other. In the past, the user was forced to work on one file to switch between application and transfer data accordingly. Now it is synchronized with each other. Those who have experience with previous generation of software and with large files know that how time consuming it was sometimes, and as you know, and time is money. In InstalSystem 5, this process has been removed. So the project scope, here we choose a thermal calculation of building. And now we go to the calculation standards and options. At this point, depending on the market, we can choose a given standard of interest to us. Currently, in InstalSystem 5, we have the option of calculating the project on as many as 4 standards available here on this list. Currently, we are working on adapting the program in version 5 to the new German standard. And this is already public information, and it should soon appear in our program as part of future updates. Work is in progress. Today we will perform calculation based on this European neutral standard. Okay, the novelty is the standard adapted to the Austrian market and the corresponding calculation printouts. This development is still being carried out, and we want to systematically increase our reach to new foreign markets. And we also hope that our next partners from other markets will also contact us thanks to this webinar to carry out the wide expansion of our software to foreign markets. Maybe I change to climatic data. Yes, here we can choose according to climate data where our project is located. As you can see, the list is very extensive, and each of the countries you see here is supplemented with climate data for the regions concerned. Each country has a flag as a clue. After choosing a given country, we can choose an interesting place for us. And I think that's all. We can move to stories management. Maybe some words about this, because I'm not talking about this much, because this aspect was widely commented on the previous building structure webinar. We are based on the previous project. We will come back to this window in the context of graphical ground modeling, but this is in a later part. That's the later part of our webinar. And now we go to the heat losses data. Please see all this information is already filled in here. The question is, why are they filled? Because we made the calculation of the building structure. The structure of the building knows that it supplements this data, and it transfers us the data on the preparation of the project for calculation of the heat load. And all these fields are filled. I go to the room data. I left the room data for the end because when it comes to there is a mechanism to greatly speed up our work in the program. What you see are the types of rooms. This is the consequence of what we have chosen as a standard form for room losses. These individual standards or its variation determine what the available pool of computing room types are. PC generally, this interface is brand new. From the left you have the general data. In the middle we have a whole panel regarding settings. On the right, however, we have the data table, which contains all the detail about the given types of room. What's important from the point of view of the data table? We can modify and set our own properties. You can create your own room types. You can click, for example, other and add. You can also copy them from the existing ones, and you can use the mechanism of loading these rooms from the template. They are loaded with the project data. However, you can create such an empty project with our room types and then load them into the project using this button. It's a restore general data from the template. In short, if a given standard does not take into account a given type or types of rooms, we create our own types and we can save them permanently in our resources. The templates themselves are saved by this button. Just click on the save as template. It really speeds up your work. Templates are the basis of work in InstalSystem 5. Okay, so much for general data. Please note that the standards and norms govern what we have in general data in this aspect. We try to present to you in this general data so that it's ergonomic as possible. The first thing I want to present is one of the first point of our webinar is that we have introduced a new data entry interface for heat loss calculations. Maybe some information about the interface itself and its ergonomics. I changed the screen arrangement to heat and energy scope. Okay. Okay, maybe in this way. What's important for us? To work in this module, we mainly use 2D editor, 3D editor, project browser, heat and energy window. That's the main change, and data table. I highly recommend this layout to modify and set it yourself. We have prepared a predefined view for users, but it's a such introduction to your own Windows settings. How to set these windows? I think we or you have mastered it well, we have made a new interface organization for introducing heat loss. This applies the entering detailed data for partitions and specific room data, for example, list of partitions of each room. Before I show you how to define such a definition of a partition, it's worth showing you what we get thanks to the fact that we have a properly prepared building structure. When I expand my project browser in our interface and then switch to the heat and energy scope, we have a list of the entire building divided into the story, then building units, yes, and rooms assigned to these building units. Okay, maybe I expand this. It's also worth noting that during the previous webinar, I showed how to properly define building units, how they are formed, and what the correct definitions influences. When our building structure is recalculated and there are no errors in this in this respect, in these windows we get all automatic partition determined by the program automatically based on calculation of the building structure. Maybe I change the layout and put the 3D view in the middle of our program, because when I change to the scope, heat and energy, okay, and maybe invisible when inactive for the construction, when I expand each of the room, okay, here thanks to the building structural calculations, you have three logical partitions. Okay, the program in this field gives us the opportunity to verify these designed partitions, the selected partitions in a project browser. For example, maybe this one. Okay. Indicates it's a logical partition and it's active in all active windows. This is great help in version 5 because we can see it all in our project very precisely at this stage. I also have this information, for example, this internal floor. I have information about this logical partition in data table of a given selected partition. So here we have all the list of the partitions thanks to automatic rooms. Okay. The next window I want to show you in the scope and on the 3D view, it's a search window. Okay. The search window also helps us to verify all of this. Now I will show you how it works. We have prepared for you some predefined criteria for searching for partitions by a given type. We can verify them at this stage. Okay, maybe I expand this view. And so, for example, by selecting a particular partition using this button, I can select all the external wall in my project. Okay, I can simply verify my project. I can simply click on the external wall. For example, it could be a wall near ground. Okay, as you can see, and, for example, or the internal wall, okay, in our project. Remember that with this window, we can also define our search criteria by using the edit button. We can also use this button to mark partitions with our specified area. Maybe I change this to the, okay. That's my heat and energy scope. And when I use the function, for example, external wall, and use the select in rectangle components as of defined type, I can click and select all the partitions with which are the external wall. I'm on the basement, so maybe I switch to the 0, and now I select all the external wall by this area, okay, and it's working in this way. Of course, on the 3D view, I can show all my type of the external wall in my project. Each selection can be a single or group and is reflected in the data table. Here we have information that in our project there are marked 3 partitions of a given type, a great solution that I personally always use and highly recommend. This is the basis of our work to do this in a highly ergonomic manner. Okay. Some information about the how to define partitions. In our new interface, I would like to show you how to build an exemplary partition definition, which we will then want to assign to the logical partitions designed by our program. Let's maybe switch to this view and expand maybe the okay, heat and energy and partitions definitions. Okay, so at this point, with this position, we have 2 small classes. One is green and one is gold. For now, I will focus on one with the green one. So when I click on the add partition definition, I can build such a partition based on my data. First of all, I can define my example partition with defined layers. It's very simple because I can add the next layers by adding this plus. I have the construction materials editor. In new interface, in then the program creating when you creating partition, a graph temperature distribution on in individual layers appears. I can view the factor, the the heat transfer coefficient here. However, I can force the program to calculate to me what layer I want to reduce to a given coefficient. When I have the next layers in partition definitions, I can click by the right button and I can reduce to a given coefficient the thickness in meters. I can define, for example, to be a coefficient of, I don't know, maybe 0.20, and I know that you can reduce the thickness of these layers. It's very simple and easy, and similar like in version 4, for example. Here we have the information about the thickness in meters, the thermal conductivity coefficient, specify heat. Then we have the density. That's the layer. That's the density, of course. Layer thermal resistance and water vapor diffusion resistance index. What I showed you is connected when we want to build partition definitions based on a partition with a defined layers. Here is the information about this. Here we have the technical data, and mother of partition definition is the part of defined layers. These are the definition of the partition, which are with partition with defined layers. However, we have another way that we will use today to count this project. These are the definition of the partition, which are partition with specify um, U coefficient. Okay, I have prepared such partition for you in a separate files. In a separate file. Once created partition can be used many times for other project. So let me maybe delete this partition definitions with that partition with defined layers. Okay, and here by pressing this golden button, you can load partitions from another project and click OK. I click and I find this. This is my definitions. Okay, I click open. I have the next window. And then I click OK. And here I have all the list of my partitions from partition definitions from my other file. First, in our new interface, we have moved specific data for a given partition of this type to the data table. Maybe I click on the external wall, because here are very important information. See how this partition is constructed. Maybe for a better visualization, I changed data table to the middle of our window. Okay, data table, and that's my partition definition of my external wall. Okay. This partition has a name, of course, has a chosen way of defining this partition. The type of this partition is specify. Okay, that's the external wall. Here we have the direction of heat flow, and note that I have the coefficient, heat transfer coefficient for this partition definition, and then note that we don't have a given thickness. Okay. Here we have important information. Default for this type. Because this field introduced some positive confusion in InstalSystem 5, by checking this checkbox, the heat load calculation is several times faster than before. This partition definition can now be automatically assigned, and here we have several options related to this. First of all, maybe I expand this list, because we can assign it with any thickness. We do not have to have the thickness of this partition definitions completed. And we have the next options. It's the match to the thickness with tolerance. It's the adjust to the thickness with tolerance. This method of partition definitions is then optional. You can, within this thickness, specify you can specify the tolerance with which the program will be able to automatically assign partition definition to existing graphical partition in the project. Why do we need this tolerance? In the case where we have building errors where it is not needed to reflect these rooms and walls, where it is not possible to achieve such accuracy, and we obtain a wall that has, for example, 24, 25, 26 centimeters, and it will be structurally the same partition, this tolerance, then it will help assign this partition definition. However, maybe we use the any thickness solution for our calculation. The question is why? Because for small houses like this is a great solution, I think, and the thickness solves the topic quickly. All defined partitions selected as default ones will be assigned directly to the graphic partitions, because thanks to the building structure calculation, as you know, we have um, already all the partitions visible in the project browser and on, for example, 2D and 3D editor. And all I have to do is make calculations that assign everything to me. Okay, so a bit about the structure of the building. Ladies and gentlemen, today we are working on our new publication marked 21.0, which brought another huge amount of news. Maybe before I can't hit load in this project, I would like to go back to some aspects that should be defined before performing a complete hit load calculation. One more thing I wanted to show you. Maybe let's get to the general data. Maybe I change to the general data in this way and go to the stories management. Okay, the first thing is that in stories management, you can define your ground modeling in two ways. The first is by put the value of story elevation. That's the one way. Here is the basement. Okay. The second way is when you click on the building, you can define your ground elevation. Okay. If you, for example, cark a project again, for example, I change the this position to minus 1.5, okay, and make only building structural calculation, we can go to the 2D editing, okay, 3D view, okay, and after this, by search window, okay, you can mark, for example, all your wall near the ground, okay, okay. The program defining our ground based on your type of partitions based on your general data, okay, based on your stories management and your position of the ground. On the other hand, we extended this functionality and in this field of construction, a new function appeared under a new icon, which we call the ground modeling. When I change to the editing screen arrangement, to the construction, and the same for the 3D view, okay, maybe I present all the walls in the 3D view, okay. Here we have the new function ground modeling, okay. This function enable graphical ground modeling using a building boundary. In practice, it works in such a way that with the help of building outline, which I will draw in a moment, we define the line which is connected the ground with the external walls. An element symbolize this ground and appears to us in the 3D view too. So just put the ground modeling. 1, 2, 3, 4, 5, and 6. Okay. I have this elevation based on my general data. When I switch to the 3D view, as you can see, that's my ground. That's my ground. Okay. Maybe for my purposes in the general data, I changed the component styles of this ground. Okay, it could be, for example, my green one with some of transparency, maybe 10%. Okay, much better. Okay, and now on the 3D view or 2D view, when you click on the label, you can define and you can use these fields, okay, to individually change the slope of this ground. This line will adjust to this external wall. For example, I could put here 1.3, okay, and here I have some kind of slope in my project. Okay, it's very easy. When I go to the 3D editor and click on this boundary, okay, I have another option, because by clicking this button, insert dividing point, I can insert by myself, the extra points or a lot of points that we represent an additional point of collapse. For example, for my purposes, I can click inserting dividing point and put this, for example, in this field, and just put, for example, 0. Okay, here is the representation on the 3D view. The program calculates an approximate appearance for you, but for the most important is this boundary which is connected with the external wall, because it determines the actual contact with the ground with the external walls. Such grounds can passes through many stories. So I think it's a very great solution. It's a very great solution because it can be one-to-one to reflect the actual situation of our project. For example, in mountains areas, or where the ground is just different shape, where it happens in principle always. Now it's only to make the calculation of the building structure, and then when you change the scope to the thermal partition, okay, here we have the this line of our walls with the ground. Okay, for example, I can click on the search and warn you the ground. Okay, so it's working in this way. So very nice functionality in our program. As you can see, I do not need to define this kind of situations very precise, because programs knows that here is the window and this wall is extended by this partition area by this window. So it's working in this way. Okay, I think it's enough to perform. It's enough to perform this calculation to to um, to redefine this appropriate dimension of our logical partitions. Great solution. I will also show you some other projects that we can achieve with our modules related to the building structure. Um, Maybe I'm now going to show you something bigger to awaken your imagination a bit about the project that our program supports right now. Um, that's the first one. Okay, that's the first one. Um, we obtained the previous project using our standard building structure path, which was conducted in our full building structure webinar. This is the path which is based on the 2D underlays, the rooms, the building boundary, and functional automatic walls, slabs, and roofs, which closes our rooms with a single click. And by making the calculation, it turns our building, our rooms to automatic ones. Um, by the way, this project comes from the BIM world and was modeled in Revit, and also from this program was from the Revit was exported to the BIM format. For example, it's IFC1. We have introduced new modules that allows for a highly automated way to obtain the structure of the buildings, and of course thermal model determining by our program. Um, when I go to the, for example, I can click visible when inactive only edges options. Okay, and I make the construction by based on this file, and here we have the all heat load model. Okay, it's very nice because, for example, you can verify your project very easy. You can use, of course, your search window. You can go to the heat and energy scope, and for example, you can check all the, for example, internal door in our project. Okay, that's our logical partition. For example, I can mark all my roofs or all my external, for example, external wall in my project. I can unvisible one of the stories, very nice and easy one. Okay. Maybe I show you the another project. It's this one. It's maybe I close this one. Okay, because I have another project for you from our program, because based on the IFC file, um, it's time for school. This is also proceed in our program in less than 15 minutes of using our mechanisms and BIM modules. So here we have the construction. Okay, based on the IFC file, just 15 minutes you can get this kind of buildings, and based on the structure and based on your automatic rooms, you can get the full uh, heat load model in our program, and that's the uh, that's the way. Of course, if anyone is interested in this subject, please visit the BIM design webinar. There I show you to obtain such a thermal model from such a files in our program. I think that is a kind of revolution, and this revolution is already available to you, which completely, I think, changes the speed of design. Okay, maybe the previous project, I close this one. Okay, let's go back to our thermal calculation. Having all types of partitions defined in our project browser window. Okay, project browser window. We can now proceed the calculation. This is the bottom in our program. It's the thermal calculation of the building and the building structural calculation. Maybe I will now perform building structural calculation and thermal calculation, okay, in my project. Okay, perfect, and see what happens when you change to this scope. Okay, we have this information earlier because I made the building structure calculation. But what's important when you make these calculations? All these partition definitions from the other project was assigned to my logical partition. Okay, that's the consequence of this this field default for this type. Okay, all of this is clearly visible in this tree in the project browser. All graphic partitions received their definitions. I think it's a fantastic thing, and it uh, is for such projects as this very easy and fast. This is all I have to do to get for this. It's the full building structure and get and make the thermal calculation results for the whole buildings. So after making these calculations, I can go to the results. Okay, and maybe I expand the diagnostic I talk about in a moment, but for this building I have all the results based on this standard. Okay, here is information about my standard. So here we have the result for the building. Everything is of course counted. We have a list of heat losses in rooms, for example, so we can check all the information and other thermal calculation of the building. Very easy, and so on and so on. Here is the diagnostic. We have only hints. This is a new class of diagnostic. The program basically only inform us that these partitions do not have the thickness entered, but in this case it's only a hint that does not affect the results. Okay, based on our schedule, I come back to the building units. I come back a little unusual and do a little step back because I would not be not be me if I did not show you a few improvements in our program that are such instructions from me and strongly improve comfort in our program. We will return to the aspect related to the structure and building units again. Maybe I change to the editing. Okay. First of all, maybe I save my project. Okay, and go to the construction and 3D, go to the construction, and maybe I hide all walls. Okay, and the same one I make with my ground. Okay, hide in 3D view. Okay, perfect. I will also show you some interesting facts regarding to modeling of thermal partition for dormer later, but now we start with these building units. Because I disturbed this order a bit, because the building units should be previously defined and there are a new product, I reserved that this operation shown here should be ultimately be performed before performing thermal calculations. The program, of course, allows us to relapse, while each relapse may cause some overwriting of our manual changes that we could have made in our project. Since at this stage these manual changes were not yet or were symbolic, we will be able to try to show you a few tricks in our program. First of all, when I go to the general data and to room data, we have the new options. The new list has appeared that allows us, which was not the case in the previous webinar, to determine whether the units are created separately for a given flow. This is the default settings, as I said in the last webinar, and in the case of such small buildings, probably more ergonomic settings. One shard, one common building unit can be set for the entire building, like in my project. When I expand my project browser, see on the list, maybe I can show you on the on building structure. I have based on this method, I have the common building units, one building units, by clicking one button. Okay, very nice functionality. In our project, when I go to the maybe 3D view, I have this building recessed below the ground. Let's call this is our basement. Yes, -1. The basement is usually unheated, and such modification, when I click on my room, this kind of modification I've done previously in my project before our webinar. So I have this room unchecked, it's unheated. Okay, that's the second one. It's the unheated room. Okay, and the second one. Okay, here we have this multi-story room, so it's of course heated room. Okay, so I have the 3 unheated rooms in my project, and when I checked my all rooms, for example, from this this project browser, 1 by clicking the control key, 2 and 3. Okay, so now I have the 3 rooms selected. Now I can move my rooms to a new unheated housing units with 1 click. Super quick solution, because just click the right button and I have the new option, create building unit for selected rooms. Okay, and the new one is created. Okay, these 3 rooms are assigned to this building unit. I can put the name for the record. I will also enter the name here. It's for example building unit. Okay, and all information are in my project browser. But that's not all. For my needs, I can make a clear distinction between these housing units in my editor in styles, element streams. It's very fine functionality because I can go to the general data, go to the component styles, then I go to the room, and now I can add the new row, or I can copy the row, okay, and it could be my, for example, I click on the Ctrl A and it's my unheated room, okay. For the automatic room, maybe I change the selection to automatic and to, for example, it could be a red one, okay. Okay, and change maybe the visibility to 50%. And then I need to change the 3D color for this one. It could be, for example, the green one. The green one, it's cold. Okay, it could be a dark green. Okay, my unheated one. Then I need to uncheck my selection. Okay, and when I come back to the 3D view, oh, too much. Maybe it could be 10% and here 10%. Okay, 3D view. And now I can select all the rooms by clicking this button, select all, okay, and I just change my 3D view style, element style to my unheated room. So as you can see, I set my building units by this list, very easy, by building units list, okay, and then click by the right button. So it's very fine. The last thing I will do is to the new function of sort function, which will sort the rooms according to their symbol. For example, I can, for large objects, a great feature that keeps our project fine. So when you click on the building units, you can click by the right button and just click sort by, and as you can see, all the rooms which are assigned to these building units are clearly now visible and listed by this symbol. For formalities, I will make maybe the full calculation to at the end, so that the program will adapt to my changes. Okay, so now it's all about this. Maybe I save this project because another thing that I wanted to demonstrate to you in terms of the structure of the building, of the thermal model and some modeling is a dormer. Okay, we have the plan about this, so maybe I can show you some solutions how to modeling the dormers in our program. We have a lot of questions about how to model dormers, how to deal with them, how to insert, for example, partitions on window type dormer when the dormer is flush with outer wall. Maybe I can show you a simple project to show you how this automation works great in InstalSystem 5. First, I will show you the thermal model of this building. Okay, that's the thermal model of this building. And I'd like to design a dormer here. Please take a look that on the construction, on the 2D editor, we have, maybe I change the level to 1, okay, and go to the construction one. We have a dedicated icon for this functionality. So uh, uh, what's important? It's a separate independent element from the roof element, and it's connected by the fact that the dormer element must be inserted on the previously calculated roof, which does not report error in the diagnostic window. Here we have the roof. Okay. Um, put just the dormer on your roof. It's very easy because just click on this functionality, and as you can see, I can buy this button. One again, maybe this simple one. Okay, it's the separate roof. Um, Now I can define such a dormer by its roof. I can determine its slope. Okay, maybe I change to the 3D view to better visualization, because here I can put, for example, a slope of 20. Okay, program automatically calculates all this information. Okay, and after calculating the building structure, the program will automatically create a front wall for us, and if necessary, if it comes from our geometry, it will create side structural walls of this partition. So maybe I show you, just make the calculation, and as you can see, we have the dormer here. That's the heat and energy model. Okay, so here we have all the partitions based on this. Remember that the dormer must not have remember that the dormer must not have a roof protrude beyond the lines of the walls. So from the point of view that it's a heat loss calculation program, it I think doesn't matter. I just inform you that sometimes we need to simplify, and I think there is no wrong with this. The dormer has a non-modifiable walls. Okay, and sliding walls with some expansion in a moment, but you can change their thickness. You cannot change that's the wall. You cannot change the position, but you can, for example, you can change their thickness, which changes from the inside of the room. Okay, because we have the checkbox on the left. Okay. Um, the dormer precisely determines the thermal partitions, as you can see. So we have all the partitions, thermal partitions, and we have the right um, cubature of the room. Okay. Um, the dormer can be divided with the same tool like the roof, with these additional edges. So if you want to change the shape of this, you can easily use this hot points, or you can use the at roof edge, very similar, like in the roof. Okay. uh, Please remember to follow the rules of the mathematical geometry. And what's new? Uh, the dormer can span many rooms, but only within one story. Remember that. So, for example, when I have this kind of situation, for example, I just put the wall. Okay. Okay. Maybe I make the collection and correct wall connection. Okay, perfect. And make the building structural calculation. Okay, as you can see, we have such a partitions. So the program automatically, for example, creates a good internal wall when we separate this kind of, and we have the dormer, which includes many rooms, but remember, only with one story. Okay, it could be only on the one story. We can have a lot of rooms, but only on the one story. Remember that. Maybe I will I can show you some more example about this dormer. I can show you some new one because sometimes we have on the project some more complicated situation, and I want to show you how to work with them. Maybe I delete this one. Okay, make the calculation again. Okay, and we have the new functionality that allows us to put the windows, for example, for hold this wall. Okay, the dormer creates its own partition by default, 30 centimeters fixed by default. Sometimes there is a situation where the window is contained with the dormer and the front wall. I can do something like this. So we have the new fields because I can check my dormer and click the new button, dormer wall replaced with a building wall. Okay, click on this, then click this one. Okay, and make the checkbox field wall is part of dormer wall. Okay, just click on this, and when you make the building structural calculation, okay, you have such a situation where you have the connected walls to each other. Then you can put the right partition. For example, I can go to the 2D to 0. I can copy them by Control C, okay, and go to the one level more. Maybe I show the shadow story below. Okay, perfect. Okay, and now I put my window. Okay, and here we have this kind of situation, and when I calculate this project, all my heat model is correct. Okay, great, great function. So that's the method of working with dormers. We can, of course, maybe I close this project. Because we can create more complicated situation. For example, this one is already in the form of demonstration what dormers we can count. For example, it could be this one, this kind of dormer. So when I change to the scope, you have all the information. We have one room, okay, and that's the another. Okay, please note that we have good room cubic capacity. Okay, that's the first one. Maybe something stranger, this one. Okay, it's the construction from our program. It's the roof with the dormer. Okay, as you can see on the 2D editor, when I change to the construction and maybe go to the first level and construction scope, this is my dormer with at roof edges. Okay, and that's my thermal model based on my construction. I have the gray when inactive, very nice view. Okay, and the last one, maybe the more complicated, but it's working in our program. It's the 1, 2, 3, 4 levels building with dormers, which include many rooms, and as you can see, that's the whole program generate this automatically. So very nice, very nice. Okay, we come back to the project because I would like to show you the issue related to the verification of project and the possibilities we have in this aspect. The first aspect is visual verification. Okay, visual verification can be carried out by using a graphical interface. The 3D interface and the search window, which I have already presented to some extent today, help us a lot on this. So maybe I open this one, the search window. Um, so how can such verification take place? Let's do it on the basis of our assigned definition of partitions and their correctness. The example will show on these partitions there are designed as partition in contact with the ground. So first of all, how to make this kind of verification? I go to the general data, go to the component styles, go to the heat and energy partition, and now I can add the new row. Okay, it could be my wall. Okay, it could be my wall new ground. Okay, and I can put another color. Okay. For this partition, I can set it, for example, a black one. Okay. So I can set many such definitions, and it depends on your needs and imagination, of course. In this way, I can return to the search window and go to the heat and energy scope. Okay. And I can use a given criterion to select all partition of a given type for me. In this case, it will be my partition of the wall near the ground. Okay, I can select all my partition are selected from the thermal partition in heat transmission calculation scope. Okay, and then we have all this kind wall near ground partitions selected in the data table. And we have the multi-select. I can assign a different style. Color, different style color to a given partition. I think it's a great help in general verification of the correctness of the assignment of given partition. Just click word new ground and all, as you can see, I have on my 3D view. Okay. I could make the same things with others. So that's one step of our verification of our thermal model. The second aspect of design the verification is a complete list of partitions with a given room. Okay, when you change to the heat and energy scope. Okay, we need wait a moment. Okay. When you click on the, for example, one of the rooms, okay, it could be maybe this complicated one. Okay, here we go. In this place, we have a full list of partitions assigned um, to our room along with further data. And this partition structure. Okay, of course I can mark every partition from this level. Just click on this button. Okay, by this button I can click and all these partitions are selected on 2D and 3D view. Of course, you can work on more than one monitor, so your 3D view could be on other sides, and when you click on this button, all these kind of elements are selected in all active windows. Okay, so from this position I can change its assigned partition definition. I can also impose it manually. So for example, when I have more types of, for example, internal wall partitions. First of all, as you remember, we can uh, change the selection of criterion, for example, to match to any thickness. By the way, you can manually switch on your design purposes. Okay. What's important in this window? We have this checkbox and we have this plus. You can add your partition by defining its appropriate properties. If you see that is something missing, for example, in my graphic model, and it's important to me from the point of view of calculations and losses for a given room, then you can add your partition structure um, and your partition definition manually. Okay, and you can assign it this partition definition. That's the first one. Okay, the second one, you can deselect, so you can uncheck this checkbox to such a partition if you notice that is not it's not correct or unnecessary from the point of view of my thermal calculation. So it's enough to deselect it. Okay, you can make this deselection from this window, or you can make from the data table. Okay, we have the same when you, for example, select one of the partition. You can uncheck the consider in calculation. You need to know this. There is some possibilities to make the manual modification based on our automation mode in InstalSystem 5. This mechanism allows me to react if we find that our program does not cover or incorrectly recognized logical partition. Remember to always verify the project. We should also remember that a partition added in tables or marked does not disappear from our graphic model. So if you uncheck this checkbox, you still have the graphical representation on the 3D view. So this tabular window of partitions within a given room also allows for more advanced settings concerning given partition. Okay, and now I will open the other project, the last one, I think, because this is the last thing I wanted to show you in this webinar. In our program, it's possible to create such ventilation air diagrams, as you can see. We have a separated scope for this. It's the ventilation L flows. Okay, it's another scope. To input data for these diagrams can be found in room data. So when you go to the general data and go to room data, and you can click on the room type, okay, for example, you can put the value to calculate the ventilation air diagrams. Okay, remember that of course the type of ventilation must be mechanical ventilation. You can, of course, on the, for example, 2D editor and 3D editor, you can put this value individually for a given room, okay, from the room data table. After setting and completing our design data, the program, after performing the thermal calculation of the building, creates and supplements the design with such ventilation error diagrams which can be very useful when designing our handling unit in our project. For example, for this one, we have the information about the infiltrating airflow rate between rooms. So we have the information about infiltrating rate. Another one, yes. And the second one, okay, that's the airflow rate between the rooms. Okay, the second one and the last one. Here we have the information about the excess exhaust air flux compensated from outside. Okay, and here we have the possibility to create such diagrams in our program. So yeah, that's the new one. So in addition, the drawing scale inform us about this data. I think that it's a fantastic thing and it's already available to users from version 18. A lot of issues that have always been asked for support are based on the ventilation airflow in old heat and energy scope. So earlier it was very hard to imagine what it looks like. Now we have everything in a graphic form. So that's all for me from this part. So okay, slowly but we are finishing this part of the presentation on my side. I hope you see this great ergonomics of our program. Maybe I close this one. So you can see that our program make a big step forward in making the heat load calculation in InstalSystem 5 version. Okay, maybe I present all the walls. Okay, yeah. It's completely new quality, I think, design, and in this case, calculating the heat load of rooms, whether based on beam files or files created on the basis of 2D basis, are very quickly. As a curiosity, I would like to tell you that we also working on exporting this data to the beam format. In fact, I can show you just the file from the development version. This is not available to you yet, but maybe I open this kind of project. As you remember, I showed you before this school with full heat load calculation, and maybe I open the free version of the Beam Vision. It's the one of the free programs. That's our school. Now from the development version of our program, you can just export this kind of files. However, this file only contain the ROMs that have been exported using our new BIM module, the building structure export. And it's not only the shape, but in our development version, we are still working on it. It's from the Polish version, but here we have all the parameters about this room. So you can get, for example, the total heat loss, for example, from this room, and we have all this information, very specific ventilation information, for example, about the ventilation of each room, and that's the IFC. Model from our program. By the way, in the printout section, we created a dedicated window which allows you to export the structure of the building. When you click in the IFC file export, you have dedicated window. Okay, and by this window, you can, for example, export only elements of the building, okay? And it could be only, for example, a room or all the structure from our building. So in this case, I only exported room data. These rooms contains our parameters, so specify in our program, calculated in our program. Yeah, so and the second thing, maybe I open this one on the other window, okay, because we can count this kind of buildings. Maybe I open this one. Please give me a moment. Okay, it's the new publication 21. Because I want to show you how even large files like this can be counted. So this is just a large real project from the south of Poland. This project has the entire heat load counted from A to Z. Okay, we need to wait a moment. I also exported this project to IFC format from our program, and this module on the export of building structure to IFC is available for you from this list, from this week. Sorry. So I also strongly encourage you to buy and buy it when you go to the free review. We need to wait a moment. Okay, that's a large building. And when you change the thermal partition, we have full, the only visible, we have full calculated heat load calculation of this building. So yes, that's possible in our program to make this kind of building. And for I don't see this in IFC, but of course you can, for example, go to printout, and if you want to have, you can uncheck and export this kind of with rooms parameters, or it could be only my for example full building structure, and it's available for you from the publication number 2021. Okay, I don't see this file. Okay, I make something wrong, I think. Okay, doesn't matter. Maybe I show you on other webinar this this exported file with full building structure. Okay, so yeah, that's the positive design from our program with full calculations. So we go straight to the ending of our webinar. So okay, ladies and gentlemen, thank you for this moment, and we are moving to the last section. It's the asking questions. So maybe I need to find this window, because I need to switch to this mode. So if Martin has prepared any question from you, and I will try to answer them as far as possible. So now I need to find any questions. Okay, so now I need to find this one. Okay, I have the information from Martin that he has been answered in a private chat for all your questions. So thank you, Martin. So okay, so that's all. So these are all questions for today. So On behalf of myself, I would like to thank Martin and the entire InstalSoft team for being present at today's webinar. We are planning in the near future for you to share additional content in the English language modules relating to the installation of our program in the form of tutorials. I hope that there will be many such meetings ahead of us. Feel free to purchase our program, promote our software, and contact us on our general mail, which is listed on the site. Feel free to positively rate this webinar, comment it on YouTube, subscribe, and contact us by LinkedIn with our official channel, as well as directly with me, especially when it comes to BIM. Thank you, and I hope I hear you soon. So goodbye.